Assalamu alaikum. Hello, everyone. In topic one, states of matter, actually, we need to focus strongly on the following important notes. Number one, states of matter. We have three states of matter: solid, liquid, and gas. So we have very important comparison between them, and we need to memorize this comparison actually. Also, we need to understand every single point in order to be able to solve questions regarding to this. First point of comparison here is separation. In case of solid, guys, we know that the particles of solid substance, they are closely packed and touching each other. So here in the drawing, you can see that particles are closely packed and touching each other. In case of liquid, so particles also, we could say, touching each other, but they are not too closely packed as in case of solid. And in case of gas, actually particles loosely packed and far apart from each other. So for the point of the arrangement, for solid, they have regular pattern. So we have regular pattern and you could say we have a lattice. Here in case of the liquid, actually irregular pattern. And in case also of gases, irregular pattern. So only we have regular pattern in case of solids only. For the point of motion or movement, particles of solids, they vibrate in fixed positions. And in case of liquid, they slide over each other slowly. And here focus in this word slowly because it might be used as a keyword in your answers. And here for the movement of gases, particle, they move random fast movement. They have random fast movement. So also here the word fast is also distinguishing from the slowly movement of the liquids. For the point of spaces among particles, actually in solids we have very small spaces. In case of liquids we have medium, and in gas we have large. For the point of compression, so actually, because very small spaces in case of solid, so particles can't be compressed anymore. In case of liquids, they can't be compressed, but in case of gases, they can be compressed. So here, guys, because of course, the large spaces among particles, so only gases, particles can be compressed. The point of density, actually, guys, solid particles or solid substance generally, they have high density. In case of liquid, they have medium, and in case of gas, we have low density. Forces among particles, forces in case of solid, they are strong, and in case of liquids, medium. In case of gas, very weak, or you could say no force, almost no force. For the ability to flow, actually, because in solid state, they have strong forces, so solid state does not flow. But in case of liquids and the gases, of course, they can flow. For the shape and volume, in case of solids, we have fixed shape and fixed volume. In case of gases, we have not fixed shape and not fixed volume. In case of liquids, we have not fixed shape and fixed volume. So actually, guys, again, we need to memorize the table very well because it's really important. And also we need to know how can we use these points through questions as we're going to see later on. Changes of matter, second point, and this is also very important. Matter can be changed from a state to another by heating or cooling. So if you look to that and from left to right, actually here we increase or we add energy. So solid is going to change to be liquid, and then liquid, if we also continue increasing energy, so it's going to be gas. If we reverse the process back by removing energy, so gas is going to be liquid and liquid is going to be solid. Here also, guys, we need to focus on these two important concepts because, guys, in case of adding energy, so this is called an endothermic change because energy is taken in. And here in case of removing energy, so this is called exothermic change because energy is given out. So let's talk about the heating processes which are classified as endothermic change. We said endothermic because energy is taken in. So this is energy is taken in. So we have actually three different processes here in case of heating: melting, vaporization. The first one is melting. Second one is vaporization. Third one is called sublimation. For melting, actually, this is a change of a state from solid to liquid by adding heat energy. Second one is vaporization, a change of state from liquid to gas, also by increasing or adding heat energy. We have to take care that vaporization could be evaporation and could be boiling, and we'll know what is the difference between them, and this is really important difference to know. But both of them actually are correct in case of they do the same change from liquid state into gaseous state. The last one is sublimation. Sublimation, this is something like changing the state from solid into gas directly in one step. This is called sublimation. So if we come back here, so if we move from solid to gas directly without being liquid, so this process is called sublimation. Second type is cooling processes, which are classified as exothermic changes. So we have also three processes here. The first one is condensation. Second is freezing. Third is desublimation or deposition, which is opposite to sublimation. Condensation, this is a change of a state from a gas to a liquid by removing energy or decreasing temperature. Freezing, or sometimes we call it solidification, this is also a change of a state from liquid to solid. And the last one, the sublimation or deposition, a change directly from a gas to solid by also removing heat energy. So all of these kind of changes are classified as exothermic changes because energy will be given out. So energy in this case will be given out. Okay. Now let's talk about vaporization, which includes two types, evaporation and boiling. If you focus on the two drawings here, guys, you could see some differences, and this is really important actually, guys. In evaporation, the first difference you could see here, we don't have any source of heating, but here we have a source of heating. So evaporation is a natural process, but boiling actually is not natural. We add a source of heating here. Second of all, here we have actually vapors here on only the superficial layer here, but we don't have any vapors or boiling down, as you see. In case of boiling, actually we have vapors, and if you look at the amount of vapors in case of boiling regarding to the amount of vapors regarding the evaporation, actually in boiling it's too much. Bubbles here, this is something not found in evaporation. Here we have bubbles also below the surface. If you check the temperature, actually this is 100 degrees Celsius. It's higher than this, and this is 25 degrees Celsius, which could be the temperature of the room. So now we have this table, and also I recommend everyone to study this table very well, and please try to memorize some points to be used in your comparison. Here the definition: evaporation, the phase it change from liquid to gas. Here boiling, the process in which liquid is heated up and vaporized. Bubbles formation here not seen, but here we have bubbles in case of boiling exist. Effect on liquid, this is on surface only, but here entirely effect. The rate, here we said this is slower process, but this is in case of boiling faster process. Naturality, we said evaporation, this is a natural process, but boiling is unnatural process. Spontaneity, the first one is spontaneous. You could see this in sea, water, in rivers, everything like this. But in the case of boiling, this is not spontaneous. So we need to add a source of heating. We need to do this. For temperature here, actually not specific. So according to evaporation, so according to the temperature, so some particle only will be evaporate to change into gas. But in case of boiling, actually we have a specific temperature, or you could say we have a specific sharp. We have a sharp boiling point actually for every substance. For external source, not required, but here required to use a stove or a Bunsen burner or whatever. Examples here like conversion of liquid into vapor phase at room temperature, but here like water turning into vapors at 100 degrees Celsius. Okay, so again guys, I recommend everyone to memorize and to understand the difference between evaporation and boiling. Next important point, if this is like an overall conclusion, so phase transition of the matter regarding to everything we have mentioned before. So this is, if you have a change from solid to liquid, so it's called the melting. From solid to gas directly, this is sublimation. And here from liquid to solid, this is freezing. And from liquid to gas, this is vaporization. The last one is from gas to solid, this is called deposition. And from gas to liquid, this is called condensation. So actually, guys, we need to focus in order to be able to solve the question. Let's apply this question from past papers. So this is which change of state takes place during evaporation. So actually, we need to check evaporation. We said this is from actually liquid into gas. So here, guys, you find this is liquid to gas. It's point B. Second one here, in which substance are the particles close together and slowly moving past each other? If you check this word, guys, as I told you a little early, this word slowly has a keyword. So I think here we said this is in case of liquids. So liquid here is water. So this is liquid state. Also, we have here another question, in which it changes do the particles move further apart? Further apart means actually we add energy, or energy is added. So when we add energy, so of course solid particles change to be liquid, and if we continue adding this to liquid, change to gas, so we need to choose Z and Y. So here you have indeed Z and Y. Okay. Here we have also another question from paper 4. This is kinetic theory explained the properties of matter in terms of the arrangement and movement of particles. Nitrogen is a gas. At room temperature, nitrogen molecules into are spread far apart and move in a random manner at high speed. Compare the movement and arrangement of the molecules in solid nitrogen. So here we need to highlight this is in solid nitrogen to those in nitrogen gas. Here we need to compare, and point of comparison will be movement and arrangement. So actually, guys, because he said compare, so we need also to make a comparison. So this is here we have N to solid. So this one again is N to gas. And the first point of comparison is so here we can have the first point, this is movement. So we said particles of solids, they vibrate. If you remember the table, they vibrate in fixed position. You can continue. And in case of gas, they move further apart. They move further apart. Okay, or far apart. The first point is movement. Second point actually is arrangement. But guys, remember here we have 3 marks, so take care. We need to mention 3 different points. So the point of arrangement, guys, arrangement includes, we can divide into here the spaces. We need to also point this to refer to the point of spaces among particles. We said in case of solids, we said there are small, very small spaces. And in case of gas, we said large spaces. And then the last one here is that because this is arrangement, so we need to refer to the pattern because we talk about the arrangement. So we said only solid particle, they have regular pattern, but in case of liquid and gas, we said we have irregular pattern or arrangement. Okay, guys, so here I divide actually the point of arrangement into 2 point spaces and pattern in order to gain the 3 marks. Okay. Next point is heating and cooling curves. Actually, this is really important point. Here, guys, we have 2 curves. The one on the left is heating, the one on the right is cooling. The one on the left, which is heating, so here actually, guys, heat energy is added or increased. So here amount of heat added, take care, and you see the curve actually going up. But the one on the right, here you see, guys, amount of heat is removed. So you see also, guys, that the curve actually moves down. So to understand heating and cooling curves simply, so we need to make this points among them, as you see, to understand every area. So actually, guys, I recommend everyone, once you check heating curve or cooling curve, to check firstly the tilted lines or inclined line like this. They are tilted or inclined. So actually, they represent the 3 states of matter. So the most down is going to be solid state, and then the one in the middle between them is going to be liquid, and then the higher one or the highest one is going to be gas. Remember, here in the tilted or inclined line, they are pure state. It means here only solid, in this case only liquid, in this case only gas. And here we have 2 lines which are horizontal, this one and this one. Actually, the horizontal lines, they have 2 or a mixture of 2 states. Here you can see gas plus liquid, and here you can see solid plus. And here also, guys, we need to say, here this is solid and this is liquid. So we can put here also the equation of equilibrium. It's very simple. This is solid, changes to be liquid, and liquid also can move back to be solid. This solid now, here, this is solid to liquid. So the process from solid to liquid, as you know, this is called melting. And from liquid to solid, once again, it's called freezing. This is freezing. And here up between liquid and the gas, so liquid, so you can write down here liquid, change to be gas, and the gas can move back to be liquid. So I think everyone knows from liquid to gas, this is called vaporization. From gas to liquid, this is called condensation, as you see. So remember, guys, very important, again, tilted lines are the 3 states of matter. And remember also, in some questions, they can give you only 2 of them, as we will see in some questions. So here again, solid, liquid, gas, and the horizontal lines, they are mixture. Here we have mixture between gas and liquid. Here we have mixture between solid and liquid. If we check cooling curve, it will be the same, but the only one difference here, as you see, this is moving down as heat energy is decreased. So here, guys, you see, also we have 3, if we make this lines. So again, we have 3 tilted lines or inclined, 1, 2, 3, and again, they are pure. So the most down one is solid. The one in between here, after it, this is liquid, so this is solid again, and this is liquid. And here, the one, the highest one is gas. So this is gas, as you see. So again, the 3 tilted lines, they are the 3 states of matter, solid, liquid, and the gas. But in the cooling curve, the curve starts by gas, then moves down to liquid, then move down to solid. Between gas and liquid, here we have this horizontal line, and in the horizontal line, remember guys, we have a mixture of states. So here we have gas and liquid. So here this is gas, moves to liquid, and liquid can move back to gas again. So, you know, from gas to liquid, this is called condensation, and from liquid to gas, this is vaporization. So once again, here we have another horizontal line between liquid here and solid. So we could write here liquid, and this is solid, and from solid to liquid. So from liquid to solid, actually it's called the freezing or solidification, and from solid to liquid, this is called the melting. So remember guys, here you need to know, in case of the tilted lines, we have pure substance, pure state I mean. So this is solid pure, this is liquid pure, this is gas pure. But in the horizontal line, actually we have a mixture. It's not pure, we have a mixture regarding to the change from one state to another state. The last important point in the heating and cooling curve is the melting point and the boiling point. So actually guys, you need to focus here the horizontal line between liquid and solid down. If you check this temperature, this is called melting point. And if you check the other horizontal line up, so this is called boiling point. Here is the same in heating curve. So here we have regarding to this point, so it's called melting point. And the one up here, regarding to this line, it's called boiling point. I know that shape it's not clear, but we'll take now some question to be more clear. Let's outline this question to understand. Substance M is a solid at 30 degrees Celsius. So here is 20, here is 40. So this is, let's say this is 30. So we can take a line between 30 to show this. So here guys, this is, he said substance is solid at 30. So here guys, at this tilted line, because this is 30, substance is solid. And this guys here, this is cooling curve. So actually in cooling curve, solid is the last state. We don't have actually anything below solid. Now this is solid one. So what's above solid as a tilted line here guys? So it should be liquid as we said. And here actually in this drawing, we don't have a gaseous state. We don't have a gaseous, only liquid and solid. So actually what is between solid and liquid, this area, as we said, is a mix between, this is liquid, and this is solid. And this process from liquid to solid here will be, yes, freezing, and from solid to liquid will be melting. So let's see the question here. Here he said the substance is heated to 80 degrees Celsius and its temperature measured as it cools down to room temperature. The cooling curve is shown. Here this is cooling curve. And between which times substance M freezing. So guys, actually here the question asked about the process itself, not the state. So here guys, we said if you check here between Q and R, we said substance from L, from liquid to solid, actually this is freezing or solidification as we said in this horizontal line. So actually this should be Q and R, so the correct answer is B. Okay? Here we have another question. This is paper 4. The diagram shows a heating curve for a sample of compound X. This is heating curve. So let's state something quickly. Here we have actually guys 3 tilted lines. 1, 2, 3. So once you see the curve, you can do also the same. So this tilted line means this is solid, and this one means this is liquid, and here is this is gas. And of course the area between B and C, this will be a mixture between solid, liquid, And here between D and B, this is going to be between liquid and gas. Okay, so is X a solid, a liquid, or a gas at room temperature 20 degrees Celsius? So actually, guys, this is 15. So let's check where is 20. So actually 15 and this is 80. Let's say 20 is close here. So let's draw this line. So you see, guys, here this is liquid. At this tilted line, as you see, tilted or inclined line, substance actually is liquid, as you see. So here, substance is a liquid. Okay. Second point, write an equation for the equilibrium which exists in the region PC. If we check PC, actually we wrote it already. It's between solid and liquid. Substance is called X. So we could write X, which is the name of substance, and then solid because it's solid. And equilibria, we should draw two opposite arrows, as you see, and it changes into X, but now in liquid state. Okay, so this is called equilibrium equation. Letter C, name the change of state which occurs in region DE. Here, guys, in DE, so actually the change here, this is from liquid to gas because this is heating curve. So actually from liquid to gas, it's called vaporization. And we said before, so this is called vaporization. Vaporization, okay? Letter D, explain how the curve showed that a pure sample of compound X was used. Actually, we need to keep this question away now because we need to study this note first and then we'll come back. If we start with the following note, guys, as you see, talks about melting points and boiling points. And remember, melting also freezing points and boiling also condensation points. We have very important usage for both of them. First important point here is melting points and boiling points are used for the test of purity, since the pure substances have sharp melting and boiling points. Therefore, impurities, if we have any impurity added to the pure substance, it should disturb the natural melting and boiling points. So actually, the rule is impurities increase the boiling point and decrease the melting point. If we apply this once again to the question up here, explain how the curve showed that a pure substance of compound X was used. So this curve refers to X is a pure substance. How come? So actually, guys, here, if we check the region PC, here we have a straight line, as you see. This is straight line, as you see. And here this line refers to only one fixed point, one fixed temperature, which is 15, which is melting point. So the heating curve in the region PC here, so we could say here, at the region PC, there is a specific sharp temperature, which is, I think, 15. So because it has a specific sharp temperature, so it's called, X is a pure substance. Second point for melting and boiling points, actually we use them to know the physical state of a substance. So we have three rules now to know how can we determine the physical state of any substance. So here, guys, in rule 1, actually if the substance will be a solid, if the given temperature, in the question usually they give us like temperature, sometimes they say this is room temperature and so on. Anyway, if the given temperature is lower than the melting point, so the substance is a solid. Remember, if the given temperature is lower than melting point. For example, let's talk about iron. Everyone knows iron is a solid substance. Melting point is iron is 1540 degrees Celsius and boiling point is 2900 degrees Celsius. And let's say the given temperature is 25 degrees Celsius. If we compare between the given temperature and the melting point, so you see here, guys, the given temperature here, 25 degrees Celsius, is lower than the melting point, which is 1540 degrees Celsius. So because the given temperature is lower than the melting point, or in other words, you could say also because the melting point of the substance is higher than the given temperature, so the substance is solid. Okay, so actually, guys, you need to memorize carefully these three rules. Number two, I consider it the easiest one because here the liquid, actually the given temperature is between the boiling and the melting point. So let's check. The substance will be a liquid if the given temperature is higher than the melting point and lower than boiling point. So if we talk about mercury, you know, guys, mercury is the liquid metal. So here you have the melting point is -30, boiling point is 3570, and here if the given temperature is 25. So here, guys, as you see, 25 degrees Celsius is greater than this, is greater than the melting point. And also here it's less than the boiling point, 357 degrees Celsius. So it's in between. So once you find the given temperature is in between both melting and boiling point, so the substance should be a liquid. Okay, and also in your explanation question, you should say because the melting point is lower than the given temperature and the boiling point is higher than it. Okay, the last point is the substance will be a gas if the given temperature is higher than the boiling point. If the given temperature is higher than the boiling point, so in case of gas, you need to focus on the boiling point and the given temperature. If you compare between 25 degrees Celsius and -183 degrees Celsius, so it's very clear that given temperature is higher than the boiling point. And this is the rule. So this substance should be a gas. Okay, guys? So to apply these rules in some questions in the exam, so here you have pure water has a boiling point of 100 degrees Celsius and a freezing point of 0 degrees Celsius. What is the boiling point and freezing point of a sample of aqueous sodium chloride? Actually, guys, this is aqueous sodium chloride. So this is not pure water. So actually, this is water plus sodium chloride, NaCl. So this is not pure. This is water, and here let's consider NaCl like impurity. So you know impurity will disturb actually everything about boiling and melting point. If you remember the rule that impurities increase the boiling point, so the boiling point of water is 100, so we should choose something higher than 100. So this is wrong and this is wrong, so it could be either C or D. And then what about freezing point? We said also impurities decrease the melting point. So decrease the melting point here should be 0. So we need to decrease it, so it should be less than 0. So it's wrong to be -2. So the correct answer actually here is C, because of the disturbing both melting and boiling point because of impurities. Okay. We have another question. Some properties of 4 fuels are shown. Which fuel is a gas at room temperature and makes 2 products when it burns in a plentiful supply of air? So here, guys, we need to know which fuel is a gas at room temperature. So because we talk about a gas, so we should check the boiling point, okay? And room temperature, if you consider it 25 degrees Celsius, or either if you consider it 20 degrees Celsius, whatever. So please, we need to check a value below this, because we said the given temperature should be higher than the boiling point. So this one is going to be wrong, and this is also wrong. We should choose one of them because they are negative and the room temperature is higher than this. Okay? So second point here, he said, and makes two products when it burns. So the first one here is hydrogen. So if hydrogen burns, actually, guys, it doesn't produce two products because this is hydrogen, so it will produce one product, which is water vapor. But here in methane, because it contains carbon and hydrogen, so it produces carbon dioxide and water. So the correct answer is going to be methane. Okay, guys? Here we have a question from paper 4. The melting points and boiling points of fluorine and sodium fluoride are shown. This is fluorine and this is sodium fluoride, melting and boiling points. So deduce the physical state of fluorine at negative 195 degrees Celsius of fluorine. So this is the given temperature. Let's compare it with both melting and boiling point. So if we put negative 195, and here we have negative 220, so this one is less than because it's negative. So we could put here negative 220. And regarding to this, so actually this value is greater than this, so negative 188. So as you see, guys, the given temperature lies between melting and boiling. So the substance should be liquid. And also we need to explain, so the explanation we need to say, because the melting point here is less than negative 195, and the boiling point here is higher than negative 195 degree Celsius. Or you could say because the given temperature, which is negative 195 degrees Celsius, is between negative 220 and negative 180. Okay, guys? The last important point in topic 1 is diffusion. So diffusion, actually, as a definition, this is a random movement of particles from areas of high concentration to areas of low concentration. So actually we have two important factors which are affecting the diffusion. Both of them are really important, actually. First one is mass of particles. So we have also very important rule you have to memorize, and you have to know how can you use it correctly. The rule says that the lower the mass, the higher the rate of diffusion. And regarding to the point of mass, guys, we need also to know how can we calculate MR, or how can we check the AR directly from the periodic table to know which one is higher, which one is lower in mass. And the second point is temperature. So also we have another rule say that the higher the temperature, the higher the rate of diffusion. So if we check here this drawing, actually, guys, this is cotton wool soaked in concentrated hydrochloric acid, HCl, and here we have cotton wool soaked in concentrated ammonia solution. You know, ammonia is NH3. If we compare between MR of HCl and MR relative molecular mass of NH3, so from the periodic table you find N weighs 14 plus H weighs 1 times 3. So actually, guys, you will find this is 17. And here H weighs 1 plus Cl weighs 35.5. So actually it's going to be 36.5. So here the mass of HCl is higher than the mass of NH3. So remember the rule, the lighter here, guys, the lower the mass, the higher the rate of diffusion. So if they start to move, so actually, because NH3 is lighter, so it will move faster, so it passes all of these, and then they're gonna meet here at point A. Here, because ammonia is lighter, so it diffuses faster, as you see. Okay, guys, so point A. Here we have another question. The rate of diffusion of three gases, ammonia, carbon dioxide, and methane, is measured. What is the order of the rate of diffusion of the gases from slowest to fastest? So we need to arrange them from slowest. Slowest here means heaviest, and fastest means lightest. Okay, so quickly we need to calculate the MR of every one of them quickly. So NH3, we set it up at 17. CO2, so carbon 12 plus O2, so 32, so it's going to be 44. And for methane, CH4, this is 4, H4 plus 12, this is 16. So it means the heaviest one is carbon dioxide, and then ammonia, and then this is methane, 16. So actually the correct answer is A. Okay, guys, hopefully it was helpful. Thank you so much, guys. See you.